Hello, this is a continuation of section 6.1/6.2. Part 3, factoring trinomials into binomial factors. We'll often need to factor a quadratic trinomial of the form ax squared plus bx plus c into a product of two binomials. While there are a few strategies for factoring such trinomials, we'll start by learning the AC factorization method. The process is illustrated below. Find the product of the leading coefficient in the constant term. List the factor pairs of AC, including signs. Choose the factor pair whose sum is the linear coefficient b. Split the linear term bx into two pieces according to the chosen factor pair. Factor by grouping. If you've done steps 1 through 4 correct, it will always work. Example 3. Perform AC factorization for each of the following trinomials. Pay attention to the effect of the sign. For these first four, I'm actually not going to use AC factorization. I'm just going to use what's called guess and check. Now, I recommend only using guess and check when the leading coefficient is a 1. So when the leading coefficient is a 1 for guess and check, I'm going to guess that it factors into two binomials. And what I know about these two binomials is that the first two terms must multiply to the first term of my trinomial, and the second two terms must multiply to the last term of my trinomial. So, what times what is x squared? That would be x and x. Then what times what is 6? Well, that would be 2 and 3. It could have also been 1 and 6, though. So be careful there. And then this is where the check comes into play. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. Combine like terms, we get x squared plus 5x plus 6. So it checks out. Just as a reminder, because some students do get lost in checking their work, that even though I checked my work, my final answer is this up here. Okay. Now, one thing I did want to point out here before I move on to the next one is I knew the 2 and 3 both had to be positive because it had to multiply to a positive and the middle term was positive. Because don't forget, they both could have been negative as well because two negatives multiply to a positive. But then our middle term would be negative. So now for x squared plus 3x minus 10, again, I'm going to guess that it splits up into two binomials. And what times what equals x squared? Well, that's x and x. And what times what is negative 10? Now here, I know it's multiplying to a negative number, so that means one of my numbers must be negative and the other one must be positive. But because my middle term is positive, that means the larger absolute value one has to be positive. So two numbers that multiply to 10 are 2 and 5, and the larger one must be positive and the smaller one must be negative. Again, I could have chose 1 and 10 though instead of 2 and 5, so we still have to check our work to make sure it works. X times x is x squared, x times 5 is 5x, negative 2 times x is negative 2x, negative 2 times 5 is negative 10. Combine like terms, 5x minus 2x is 3x, so we get x squared plus 3x minus 10. So it checks out, and again, x minus 2 times x plus 5 was our final answer. The next one, we have x squared minus 23x plus 132. So again, I'm going to guess that splits into two binomials. What times what is x squared? X and x. And then what times what is 132? So because it's multiplying to a positive, I know they have to be the same sign. And since the middle term is negative, that means both of them have to be negative. Now, what numbers multiply to 132? We get 6 and 22, 2 and 66. We also get 11 and 12. Let's see if that works. X times x is x squared. X times negative 12 is negative 12x. Negative 11 times x is negative 11x. Negative 11 times negative 12 is 132, which, after combining like terms, is x squared minus 23x plus 132. So there is our answer. Okay, we have x squared minus x minus 56. Again, going to guess two things. But this time, because I'm multiplying to a negative, one of them has to be negative, one has to be positive. But since the middle sign is negative, this time the larger number must be negative. So what times what is x squared? X and x. And what times what is 56? 7 and 8. And the larger one must be negative. Check the work. We get x squared minus 8x plus 7x minus 56, which is x squared minus x minus 56. And there we go. One warning is that some people teach this that it has these two terms have to multiply to the third term and add up to the middle term. When the leading coefficient is 1, that does work. When the leading coefficient is not 1, that trick does not work. So I just recommend not. It doesn't save you that much time, so just don't use it. Okay, now the last two examples for the notes do not have a leading coefficient of 1, so we're not going to guess and check. Instead, we're going to do what I like to call the asterisk method. Now, the asterisk method will only work if you factor out the GCF first, which you should always do anyways, and if the first term is positive. So if I look at 4x squared minus 5x minus 6, the first term is positive. Good. And 4, 5, and 6 have no common factor, so there is no GCF. So now, for the asterisk method, draw an asterisk, hence the name, and then A times C goes on the top, so 4 times negative 6. B goes on the bottom, so negative 5. Do not forget the signs. And then AX goes in the top left, and AX goes in the top right. Now, to get the bottom left and bottom right parts of the asterisk, you need to guess two numbers that multiply to negative 24 and add up to negative 5. In this case, after a little thinking, we get negative 8 and 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So there we go. Now the asterisk is giving you two fractions. You need to reduce these fractions. So 4x over negative 8 reduces to x over negative 2. And 4x over 3 does not reduce. Now what our answer is x minus 2 times 4x plus 3. And we have it factored. Okay, the last example, 12x squared plus 60x plus 75. The first term is positive, check, but 12, 60, and 75 have a GCF of 3. So I'm going to factor out the 3 first. We get 4x squared plus 20x plus 25. So now I'm going to be factoring what's left in the parentheses using the asterisk method. So A times C which is 100, b, which is 20, 4x, and 4x, and then what times what is 100 and adds up to 20? 10 and 10. Reduce the fractions. We get 2x over 5. Oh, and I'm on the side of the page here, but that also becomes 2x over 5. So then our answer is 3. Don't forget the 3 from the GCF. And then 2x plus 5 from the first fraction, and then 2x plus 5 from the second fraction. And this can be rewritten as 3 times 2x plus 5 squared. And that is how you can factor quadratic trinomials.